Moving on to our next speaker here, Carlo Van Herk from Farming Smarter. He's speaking on PGRs, maximizing barley yield while minimizing losses. Carlo currently leads the field operations team, overseeing everything from the early trial stages of preparation to the late stages of harvest and analysis at Farming Smarter. He works closely with shop manager Toby Mandel and a rotating cast of summer students to ensure equipment is well maintained and trials are mapped, upkept, and looking nice.
There we go. So my topic is on maximizing barley yield while minimizing lodging. So when we first got this project here at Farming Smarter, we always like to have a little bit of fun with the names and what we call our projects. And to be honest, this project name was just too long. So instead of always calling it the Maximizing Barley Yield While Minimizing Lodging Project, we made an acronym and we called it MIMBY WIML. But believe it or not, that was even still too long. So the next year, it got shortened to MIMBY. So I'm presenting to you today on MIMBY, maximizing barley yield while minimizing lodging. So barley is an important crop here in Alberta. There's 3 to 4 million acres grown each year. It is the third most grown crop in Alberta. And lodging with barley tends to be a topic of concern. There's a couple of things we can do to control lodging that are in our control. So that would be adjusting your seed rates, lowering your nutrients, of course, decreasing irrigation if you must. And then there's a few methods of control a few effects of lodging that just aren't in our control, and that would just be wind and rain. There's one other method of control, and that's called plant growth regulators, or PGRs. There's 3 PGRs currently registered for use in Western Canada. That would be Ethereal, Manipulator, and Moddus. So Ethereal is an older chem. It was registered in 1965. It's used a lot to promote ripening in fruit crops. So it's used a lot more in the fruit production areas of agriculture. It really stimulates flowering and can get an even color across the fruit crop as well. But it also shortens wheat plants, so it's also used for controlling lodging in wheat. Manipulator, it was registered for use in Western Canada in 2014 for wheat, and then in 2020 it was registered for barley and oats. It was seen as more of a safer option than Ethereal, as Ethereal seems to be very picky on the stage that you need to apply it. And then the latest one is Moddus, which was registered for wheat, barley, and oats in 2021 here in Western Canada. It's a newer chem. So they prevent lodging, but how do they actually work? So PGRs, there's 2 different modes. The Ethereal works a little different than the other 2. Ethereal is essentially ethylene. So it works by inhibiting vegetative growth in plants. So technically what it does is those little microfibrils you see in the cell wall, instead of having them grow up, it has them grow sideways. So essentially, the plant cell grows isodiametrically, so it grows just as wide as it grows tall, instead of just growing tall. Essentially, we're creating thick but short stems. Manipulator and Moddus, they work through gibberellin biosynthesis inhibitors. Essentially, they slow cell expansion. And so the gibberellin is a plant hormone that play fundamental roles in plant growth. They're involved in every process from stem elongation all the way up to flowering. And I've got a little video here to talk a little bit more about gibberellins and if there was audio. We'll start that one over when you're ready.
Having been made in the tips of the stems and roots, auxin is moved in solution by diffusion to older parts of the plant. In the stem, the auxin causes the cells to change in elasticity. More elastic cells absorb more water and can grow longer. Strangely though, stems and roots respond differently to high concentrations of auxin. Whilst the stem cells grow more, the root cells actually grow less. So auxins make plants grow.
So you might remember from bio in high school what auxins are. So auxins work together with gibberellins then.
Gibberellin. Once a seed germinates, the roots and shoots start to grow. But for this, the seed needs energy. Luckily, the seed releases a hormone called gibberellin, which causes the starch in the seed to turn into sugars and provides the seed with energy to grow. As well as causing shoot growth, gibberellins can also stimulate flowering and the production of fruit in some plants, and they also work with auxins to cause stem elongation.
So essentially, through inhibiting gibberellins, the internodal length of our plants are shortened, is essentially the short way of going about it. But I'm here to talk a little bit about Moddus. So as I mentioned, Moddus is registered for use on wheat, barley, and oats. It's provided by Syngenta. The active ingredient is trinexapac ethyl. And the current label application for Moddus is, the main application is either through a single application at growth stage 30 to 32. So that's really at that noding stage over there, as you can see in this image. So 0 to 2 nodes is the highest recommended application stage. And there's also another split application on the label for between growth stage 21-24 and 37 to 39. So that 21 to 24 is your tillering stage of your crop, and then that other one is the flag leaf stage. And I have a couple of these images. I didn't use the wonderful AI images that Trevor had on his presentation, but this is essentially more, on the picture on the far right there, is kind of this latest stage you would want to target your application according to the label. So the goals we hope to achieve here was see if we could push the label a little bit on Moddus, and of course, can we minimize lodging while maximizing yield? So the study was put together by Dr. Sherry Stridehorse when she was still at Alberta Ag. However, when that fell through, it got picked up by Laurel Thompson at Lakeland College, and then Laurel Thompson went to mat leave, and then it bounced hands a couple times, so then it ended up being finished up here by Dr. Balwinder Kumar by Lakeland College as well. So there was 3 sites, 3 years, and 3 varieties. The 3 sites, of course, would be Lakeland College, Farming Smarter, and then we also included Started Ag Research up in Peace. The 3 varieties that we looked at were AB Haig, CDC Austenson, and ESMA. Now, originally, Moddus research was done on a lot of the older varieties, and Moddus research was not actually done on some of these newer varieties that are now available in the market. So these 3 varieties are chosen. They all act a little bit differently. Haig, for example, is a much more of a forage variety. It puts a little bit more energy into leaf production, especially under stressful situations. Compared to Austenson, also known as a high grain yielding variety, grows tall, but it puts a little bit more of that energy into grain production compared to leaf production. Then you have ESMA, which is a European variety. It's registered as a malting variety in the US, but over here it's just considered a feed grain variety as well. So we came up with 9 different treatment applications. Of course, our first one is our untreated check, where we won't be applying any PGR or any Moddus throughout the span. Our second application then would be our half rate at tillering. So that's that the early growth stage that I mentioned, the 21 to 24. Then we decided to do a half rate at noding stage as well, and then of course as well a half rate at the flag leaf stage. I just want to note that whenever we did a stage at tillering or at flag leaf, we would tank mix it as well. For example, for the tillering, we would throw in a tank mix of herbicide. When we applied it at the flag leaf stage, we would tank mix in a fungicide. However, all the plots did receive a fungicide as well. For example, if on treatment 4, we would apply our PGR, tank mix with our fungicide, and then we'd go and we'd blanket a fungicide over the leftover plots. So there was no confounding effects between some plots receiving fungicide or herbicide compared to other plots. Same with the untreated check. It also received a fungicide. It also received the exact same herbicide. And then we go into our full rates. So we did a full rates application at the noding stage. We also did a full rate application at our flag leaf stage. And we did a split application at the tillering and the flag leaf. So this is hitting that early stage and that late stage. So for the split app, which is the current label split application recommended rates. Then we also did the split app at tillering and noding. And of course, the other option there is a split app at noding and flag leaf. we collected the usual data. We looked at plant heights, of course, is probably the most important one to consider here. We took lodging notes throughout the year. We did some date collection, for example, the date of boot emergence or even maturity ratings dates. And then we looked at yield and grain quality. So let's get a little bit into some of the data here. So for example, for all the data here, I'm splitting up for between varieties, as different varieties do tend to act a little different, even though, as you'll see in the end, the overall trend is similar. So here we'll look at specifically the AB Hague, the heights. So you can see those two orange bars over there, statistically were the shortest treatments after PGR application. The first one being the shortest is the high rate at flag leaf, so that's at late application. And then the second one being that split up between the two node and the flag leaf, so that's the middle and the late application. And we can see in that next grouping there, all these treatments statistically the same here, go all the way down to where a low rate at flag leaf, which really leave out the only these four being similar compared to the no PGR applied, being that half rates at the earlier stages. And thank goodness we could see that the no PGR was the tallest, so that was good. So same with the Austinson here, we see the shortest treatment on its own there is the high rate at flag leaf application, just like the Hague. The next grouping there, we see more of those later application dates. We see like the split app, both of them having the flag leaf being the next two shortest, and even the low rate at flag leaf. So here we really see the flag leaf application standing out as resulting in shortest plants. And then of course for the tallest plants, we see that no PGR, and then with our low rates at that earlier staging, you see that 2-tiller and the 2 no treatments there. And then let's look at Esma. So Esma on its own is already a shorter variety. On average, it was about 17 centimeters shorter than the Austinson over all 3 years. So it didn't have as much of a difference in height when the PGR was applied. But there were still some trends. So we see, once again, the high rate flag leaf being the shortest treatment there, and it being quite similar to a few other treatments, but once again, all those later applications. And then we have the tallest treatments here on the groupings. These are all statistically the same as a no PGR. So really the only two that stand out are the high rate flag leaf here. Sorry, the only one that stands out. Now, of course, we took plot photos throughout the year as well. So I just want to use this to kind of demonstrate the height of some different plots. So using our 6'4" summer student over here and his legs, I can demonstrate a little bit the height difference we had between plots. Honestly, these pictures were just by random chance that he was standing there, so it worked out pretty well. But as I was scanning through pictures, I found them and decided to use them, and they worked to show really the difference between the no PGR and then what we've been seeing as that high rate flag leaf. And I'm pretty sure this is an Austinson variety over here, actually. So yeah, just off of the angle of the camera, you can see the difference in height. So let's look at yield. Is yield affected? For the AB Hague, there was no statistical significance in yield, which is great because we don't want our PGRs to be hurting our yield. We do see that our highest yield is the high rate at 2 node, but we can't say that it has any significance compared to any of the other treatments. However, on the Austinson, we did see a bit of a yield bump by having that split up at the 2 node and the flag leaf. And if we remember correctly, this was also the second shortest treatment once we looked at the Austinson. I'm pretty sure it was second shortest for the plant heights. So this treatment really is only significant compared to the no PGR, which is wonderful. So we see the no PGR having a slight decrease in yield. Esma was a high yielding variety. It's really an awesome variety here. It's yielded highest than anything else, but hardly had any difference in yield compared to treatments, which was great. So when we look at lodging, there was a lot of differences. Each year was a little bit different for data. There was lots of irregularities to the data. There's this word we were looking for, Terry. I forget what it was, and I remember you came up with it. I was going to write it down in my notes here, but I forget. The data just wasn't sound. But I do want to point out one thing here, and that's by comparing the difference in varieties. So we can see Esma, being the shorter variety, had a significant lower lodging rates compared to the Alberta Baby Hague and the Austenson variety. Just make that orange there. So this really just shows the importance in a good variety choice for when you're going about your selection for barley here. So through all of this, I want to talk a little bit about the best strategies we get here. So as you might have picked up on the trends, our best strategies here for managing lodging in barley using Moddus is by using a full rate application, either through a split app or through a single rate, or through a single application, sorry, and for targeting that later application. The later application really showed benefits in the heights, and even in the Austenson, it showed a little bump in the yield. And once again, it's important to point out the choice of a good variety. When you're going through your varieties, talk to your seed dealers or go through the Alberta seed guide. Look for those ones that have the very good standability. If lodging is a big issue for you, that's an important thing to remember. So we've shown here, Esma being a great variety. It's a little shorter already. It withstands lodging a little bit better. And if you are going to apply PGR, avoid stressful times for your plants. When you do apply the PGR on the plant, you really are stressing it out. And if there's already other environmental effects or other causes that make the plant stressed out, adding that PGR have the possibility of wrecking your yield or causing other detrimental effects. Specifically, as we could see in some of the data there, that AB Hague, like I mentioned, under stressful times, it puts more energy into leaf production compared to grain production. So having that split application on the Hague didn't tend to do as well as it did on the Austenson. Because the Hague, we stress it out twice by applying a PGR, put more energy into leaf production instead of grain production. So really knowing your varieties there and avoid your stressful weather events, right? You want to avoid your droughts or anything else. But to do that, of course, you need to scout often as well. So really know what stage your crop is at. So if you are going to apply a PGR, you can be confident at what your stage is, and when you're ready to apply, and when you want to apply, you know you're ready to apply. And big thing then is follow label instructions. PGRs, especially when you tank mix them, they can be a little tricky. Follow the label, the mixing rates, the mixing instructions. If you have any questions, always call the company. That's what I like to say. So, yeah, those are really your best strategies for applying your PGRs here. But is it worth it? That's the big question. That $16 an acre, it could be a big little additive to throw into your sprayer once you go out. But it depends on your operation. If lodging is the bane of your existence, PGRs could be the answer. It could really help you avoid that yield loss due to lodging, have consistent staging, and nobody hates flat barley crop at the end of the year more than farmers. So if you could avoid those harvest delays over there, it might be the answer for you. So through all this, I decided that MIMBY had to become a word. So I hope everybody now is going to be awesome MIMByers. If there's any questions, yeah.
Carlo, did you run that down south this past summer?
Yep.
And did everything fall flat? Doesn't matter what you did.
No, actually. We had struggles with lodging this year. We would run the pivot over, dump the water on. We had all of our nutrients maxed out. We struggled for it to lodge this year.
Because there was more lodging in most irrigated areas this year.
We had other trials lodge, but for some reason this one did not want to go flat.
So we didn't learn anything. Because we put Moddus on and all fell over.
Interesting. Okay.
This year.
If you don't mind me asking, what was your application stage?
I have no idea. Ask George.
We did ours at GS32.
Okay.
And we had two different varieties, Claymore and Esma. They both went flat. We watered them heavily. We had max nutrition in the field. So I'm kind of wondering what two things. One, your nutrition levels in pounds of nitrogen per acre, and population of plants per square foot.
So population, we went a little lower. We targeted the 250, we go everything seeds a meter squared. So 250 seeds a meter squared. So It was about 75% your regular rate, I'd say, we went. And then for nutrition, like I said, it was maxed out. I don't know the exact rates. Maybe Mike remembers off the top of his head, but yeah. We maxed out our drill and we broadcasted, so it was, yeah, not in excess. Or sorry, it was in excess, that's what I meant. Yep. Yeah, like I said, we struggled with getting this trial to lodge this year. We had like Trevor's rolling cereals, went flat. We had some other barley projects, 100 meters to the side, and they went flat. But for some reason, this one did not want to go down. Yeah.
Nothing on Slido. Nothing on Slido. Any other questions from the floor?
Did you guys run this on manipulator as well, or was it just Moddus in this specific instance?
It was just Moddus. We just worked with Syngenta on this one. Yep.
Okay.